Okay, we're going to look at chapter 15, which is equilibrium, and this chapter and the following two are all about equilibrium. This is the big basic equilibrium chapter, and then 16 is acid-base equilibrium, and 17 is just some additional little pieces about equilibrium. So the first thing we're going to start off looking at is what exactly is equilibrium. Okay, in equilibrium, you'll see a lot of this double arrow. Okay, so the reaction's going to be going back and forth, which actually most reactions do go back and forth. Very few actually go totally to completion and totally to the right side. So we talked about these back and forth arrows when we dealt with weak acids and weak bases, and we're going to look at those and a few other things as well. Okay, so the first thing is, what exactly is equilibrium? Okay, equilibrium is where your concentrations of your reactants and products remain the same. And most reactions, like I said, are equilibrium reactions. You're going to see that lovely double arrow. Okay, these are going to be the ones, again, where you're going to have to the left and to the right. You have what's called a forward reaction, which is usually to the right. Okay, and you have the backwards reaction. That's usually the one that's going to the left. So if you hear forward and backward, forward usually means to the right, backward to the left. All right, when we talk about equilibrium, if your concentrations of your reactants and products have to be the same, it's not static though. It is not something that's just going to stay the same forever. So it's not like it remains constant, meaning my reactants never change, my products never change. Okay, your concentration of your reactant is not necessarily equal to the products. Okay, they're just going to stay the same at whatever spot they are at. So I could have a concentration of 3 for my reactants and say a concentration of 5 for my products. So the numbers aren't necessarily going to be equal. They can be, but they're not always. Okay, and the molecules still are moving and still reacting, but my rate, which we're going to look more at later on in the year, remains the same. So the amount that one changes into the other stays the overall same. Okay, so you're changing from a reactant into a product, and that amount that changes is going to stay the same. Okay, so we're going to look at this figure, okay, and yours is actually to the right, all right, for the changes in concentration in a reaction over time. So I have this reaction between N2O4 and NO2. Okay, so N2O4, those are my reactants, okay, NO2, that's my product. So when it starts off, notice how the NO2 is really low because it's a product. I don't start off with any of my product, okay, usually. And then my reactant, I start off with a whole bunch. Well, over time, my reactant turns into product, so my reactant concentration goes down, but my product concentration goes up. Okay, so notice how they cross, okay, but that's not equilibrium. It is not where they cross, okay, it is where they start to stay constant. So notice how this NO2 concentration is staying the same and N2O4 is staying the same, but they are not equal, okay? So again, my concentrations are constant, okay? The reaction concentration never goes to 0, which is going to be a really small amount compared to my product, okay? And my equilibrium stays this way unless you disturb it. So unless I add something to it or take something from it, my reaction will stay with those concentration. And we say that this reaction lies to the right, okay, because the right side are my products, and so I have way more products than I do reactants. So we're saying that it lies to the right, because notice how my products up here, I have more of than my reactants. All right, so we're going to look at this little chart to the right before we look at this stuff to the left, because actually this chart to the right actually goes along with that chart above it, okay? So instead of comparing my concentration, now we're going to compare my rate. So notice how if I start for this reaction, okay, and don't worry about this yet, we haven't talked about what those mean, all right? But the F means the forward, the R means the reverse. So my forward reaction rate, okay, how fast it's going, starts really fast and gets slower. Because as I'm using up more of my reactants, I have less to use, so the rate itself kind of gets slower and slower and slower. Whereas my rate for my reverse reaction, the little R one there, is basically 0 to start because I don't have any products, but then over time I have more and more and more products, so more and more of my products are turned back into reactants. So it starts off really going fast to the product side, and then over time as I get more and more products, it starts going faster from the products to the reactant side, until eventually my rates are equal and equilibrium is achieved. So here is where my two rates are the same. They kind of slow down and we end up having the same amount going both directions. We're going to look at that in the model equilibrium activity here in a little after all your notes, okay? So notice how then the concentration one, okay, they are different concentrations, but they're equal, Okay, or they stay constant, I guess I should say. Whereas when we talk about rates, rates are going to equal when your equilibrium is achieved. Okay, so now into something different. So actually, like I said, this has nothing to do with that chart. Okay, if I add more of my reactant, your equilibrium is disturbed. Okay, so if I add more of this reactant, I disturb my nice equilibrium, has a nice constant concentrations. What happens is I'm going to form more products because I started off with more reactants than what I have of my products. So you add more of these reactants, it gets disturbed, I make some more products, but eventually then it settles back down and we're back to that nice equilibrium again. So if you mess it up, it fixes itself, and we're going to look more at that at the end of the chapter.